So, I'm gonna do another triangle. Um, the sound of triangle. This one's root 2, root 3, root 5. I'd like to do, I don't know what like an irregular cube is called. A hexahedron. I'd like to do one like a root 2, a root 1, root 2, root 3, three-dimensional shape, where one side would be root 5. But for now, I'm just gonna do a root 2, root 3, root 5. So I have them all laid out underneath here. I drew the proportions, but yeah, I drew the proportions on here. But now I'm going to trace them for each one so that I can get the peaks and troughs, and then I don't know, go from there. Just trying to understand waves and the way they interact, and I don't know. Hope it's interesting. Okay, so I have my root 2s laid out. Okay. So this is root 2, and you can see, well, I'm not sure if you can see, but there's that faint line. Like, this is root 2. This is root 2 over 2. This right here is 1, which maybe you can faintly see. But anyway, so this is root 2, 2 root 2, 3 root 2, 4 root 2, 5 root 2, 6 root 2, 7 root 2's off the page. So then I have my root 2's bisected. Root 2 over 2, 3 root 2 over 2, 5 root 2 over 2, or wait, that's root 2, so that's root 2 over 2. Yeah. Root 2 over 2. Root 2, 2 root 2. Root 2 over 2. 5 root 2 over 2. 7 root 2 over 2. 9. 11. 13. 14's off the page. And then I have those areas bisected, because root 2 is the period, or the wavelength, rather. So somewhere in here, our wavelength is going like this. One of the questions I have is, like, naturally, like, we can make the amplitude be whatever we want if we're just playing around, but one of the questions I'm trying to answer for myself is, what is the natural amplitude? When I create the sounds for this demonstration, I'll likely make the amplitudes, which is my understanding of volume, as in, you know, how it sounds, I'm going to make them all the same. But I'm trying to figure out the geometry of the natural amplitudes of how they would actually be in reality, if that makes any sense. And part of that I think of is like amplitudes would somehow be like imaginary ellipses. So if something was existing completely in the real plane, it would be a perfectly circular amplitude, so that the amplitude would equal the radius. But once we emerge into the imaginary realm, the amplitudes become ellipses. So like, if the rim of this cup were the amplitude, never mind the cone part of it, but so now the height is less, the amplitude is less. Now the height is 0, the amplitude is 0. Now the height is equals, twice the radius, or the radius, or whatever. So that would be complete. But I don't understand that yet, but I'm trying to understand that. And now's a good time to note that my videos are just really notes to myself. And if someone were ever to find, which I find completely doubtful, because I wouldn't say I'm convinced, but sometimes I wonder, am I the stupidest person in the world? I mean, all this stuff aside, like, it's hard to imagine. It's hard to imagine anyone dumber than I am. And if you are someone watching this and you don't understand what I'm saying, that doesn't mean you're dumber than me. You could very well be very much smarter than me. It's just that those who would be way smarter than me understand what I'm saying way more than I do. I guess that's just a side note. But anyway, so this is where I'm at with Route 2. And I'll fill that out and then move on to Route 3 and Route 5. Alright, so so here is my Route 2, and now I've done my Route 3 similarly. You can see it's larger. Now I'll go on to Route 5, and again, as part of my measurements are concerned, I feel pretty good about the way that I'm dealing with the wavelengths, even though the Route 2, Route 3, Route 5 triangle, like, what is that exactly, and how does that penetrate into the imaginary realm? Is a Route 2, Route 3, Route 5 triangle possible in the plane? And if it's not, what does it represent three-dimensionally, even if those three dimensions are two real, one imaginary, two imaginary, one real? It's hard to say. But similarly, like, I've often thought about how in the beginning of things, like in the beginning of human history, like, straight lines seemed like they would have been very difficult to come across. So it's not unreasonable to think that a lot of the beginning geometries were circular, because, a broken branch with two, a branch that branches off in two could be placed in the ground and twisted, and like a complete geometry could have been completed this way, which also makes me think about the beginnings of language. Like, so much of the beginnings of language go back to, I guess, what they call like Coptic or Babylonian. Again, my understanding is that there isn't really Babylonian, that there isn't a preserved Babylonian language, that what we call Babylonian is Mesopotamian. But that was all in the clay, in the desert, And it seems as though we emerged more from a tree type of place, from a place where there were trees, so there was ample ground, there was ample branches. So circularity in geometry seems primary, as does a language written on sticks. And I think we see a lot of that in like Northern European or Scandinavian early languages. I don't know a lot about language. But in studying early geometries and in studying early languages, early geometry seemed to correspond to something which was more completely circular, because lines seem harder to come about. To make a perfectly straight line out of nature, besides staring upon, the horizon of a or the plane of a body of water, but how to replicate that seems very difficult. But the whole idea of branches and sticks and twisting, that seems pretty natural, as does writing on a stick, no paper, before clay, before baking clay, before fire, carving a language on sticks, marks on a stick. That seems more natural. I'm not really going to get into that, but as far as like circular geometry goes, like coming about dividing a circle in sixes, very natural, piece of cake. But then to divide a circle into 12s without a ruler, without a straight edge, just with circles, seems very difficult. So that's a large concern of mine. This was my first attempt, which I've yet to prove whether or not I'm quote-unquote right about. Like, I tried very hard to figure out a way to divide the circle into 12. I think this was wrong. I think this might be right, but I haven't proven it. I do the work in my head as I go, and then go from there, while I also, put these straight edges in. In the end, it's all like trying to think spherically in a plane, it's just so fucking hard. Like, it's really hard. And anyway, back to this. The whole reason I went through all of that is because I'm not saying this is right. I'm just trying to find a way to understand things. And the root 2, root 3, root 5, like, if it's not right in the plane, maybe there's a way in which understanding it in the plane, which is my way of using wavelengths and frequencies to come up with interference patterns, like maybe that speaks to the imaginary realm or the Z axis or something. And in a world, I'm shamelessly justifying my actions by saying, in a world where there's no unified theory, if there isn't a unified theory, there's not an accepted or a known or popularly known unified theory. Does that mean it's not out there and that it doesn't exist and it's not a secret? No. But in a world where it's not the popular, everyday, common sense, commonplace vernacular, it's a problem that needs to be solved. It needs to be brought into the commonplace. Whatever can be known needs to be known. I fully accept that I'm mostly, if not completely wrong, but I have to as we all have to. Like, we have to start where we are, looking at things best we can. And I don't mind being wrong forever. If once, if I can contribute in some very small way to the rightness that has to at some point be, has to at some point come about. The new thing, the next step, the new thing coming. And if it's not to come in, me or you or the next person, like, so long as it comes, not to forfeit ourselves, not to sacrifice ourselves for nothing. It's just even though I'm a no one. We live in an age where all this information is available, and the whole point of like the internet and all the the YouTube and all the computer stuff isn't to make, like, not that it's not to make, people talk about the technological singularity and all this, but at the end of the day, it's really about, we have access to all this information, and we have the access to all this information so that we can think bigger. We can think more things in one moment, and every moment doesn't need to be only saturated with one thought, but that all these thoughts can come together, and not just like, for instance, in this picture, I have my 6 root 2 and my 5 root 3. They're very close together. They look like they meet. I know you can't see it here. But my 6 root 2 and my 5 root 3, they look like they're the same thing. They almost look like they're the same thing within a certain resolution, but they're not. They're really close, but they're not the same thing. So to come to that level of discernment is what technology is all about. It's not about building, the next best mousetrap. It's not about building the more efficient car. It's all about that we can learn the way things fit together, and we have more access to all the world's information of the ages, like the way ideas reach through time. There might be someone who wrote something back in the 1200s that was for you to read. It wasn't for anyone else. Millions of people may have read it. No one may have ever read it. But somewhere on Google, it's there for you. Because that's the way it works. That's the way eternity works. And now, eternity itself has a hand. Has a hand like it never had before to reach to you. And yeah, there's all the algorithms and all of this and all of that people do and things do and mechanisms do. But at the very fine points of things, at the places where we think things meet and they don't, these two things don't meet, but one of them may meet you, and one of them may meet me. And then at some point, you and I meet each other in some other place where something else meets for someone else. And to me, that's what it's all about. And I'm being poetic with that, but it means something. Anyway, that's Route 3. We'll get to Route 5. Sorry for the theatrics. Okay, so I got my root 5 done, but just to pick up on a point for my last one, like 6 root 2, 5 root 3, both very close to 8.5. And if if your pencil width were 8.66 and so on, minus 8.48 and so on, you would have an apparent meet. And in applied math, that would be fine, depending on your resolution, if you were doing a certain type of gearing and so on, but in perfection, not fine. You know? So if these things seem to meet and they don't in perfection. So yeah, this was my root 2, root 3, root 5, bigger. So I have a lot of work to do in establishing my peaks and troughs and so on. That's where I'm at with that. But then root 5. Like, what is that exactly? And again, I already talked about like circularity, and you know, when you're doing geometry in this quote-unquote Euclidean sort of way, where you're using circles and lines, it's been pointed out by others that this is a form of cheating, you know, and there are so many ways to come about root 5ness. You know, in some sense, this is root 5. This is root 5. This has to do with root 5. Root 5. Root 5. Again, my other picture, root 5. Root 5. I mean, this is a lot of plus or minus root 5 plus or minus root 1 over 2 and over 1 and over whatever. 5 and 6, root 5. Root 5. All this stuff, root 5. Root 5. But how does it relate to sphericality? Root 5. And then that comes to like three-dimensionality, because I'm dealing with this Cartesianally. If I'm dealing with a plane of a perpendicular x and y axis, there is a implied perpendicular z axis. But three-dimensionality at its root, to me, I mean, so far, and I'm trying to figure out how I'm right and how I'm wrong, but it has to do with tetrahedrons. Now, dealing with tetrahedrons, I was wrong about that. I was wrong about that. This might be partially right. I was wrong about that. Here, I'm getting closer. And again, it's not like it's me who figured these things out. I mean, there are eternal truths and we come to them or we don't. But this is a little closer to tetrahedronality, shy of true perspective. Yeah, but like this, I mean, because in 3 dimensions you're dealing with 4 points, and 4 points is most naturally a tetrahedron. And a tetrahedron at least seems to be in complete contradiction to Cartesianality. I know it's not, it can't be, but it's so strange. You get all these strange shapes depending on how you're looking at it. And this at least seems to correspond to the quote-unquote Coptic, the quote-unquote Mesopotamian, quote-unquote Babylonian. And this is, while I'm talking about tetrahedra, it's worth to note that something that took me what would be considered a half a lifetime, 40 years to figure out, is this Psi margin. The Psi margin seems to be so important, very much wrapped up in some proportion of root 2, but like a tetrahedron in a sphere, a tetrahedron has 3 triangular faces. And in my mind, for so many years thinking about a triangle, I would have thought that the triangle meets the edge of the sphere, but it doesn't. It sits below the diameter or the hemisphere of the sphere. So you get this gap. That seems very important. But anyway, all these things about tetrahedra, a tetrahedra, it has it all. 4 points, 6 edges. And 6 edges, to me, I only read and have been exposed to very fifth columnist material. Stuff very far removed from primary sources. But I'm trying to work my way back to primary sources. But I've been sufficiently convinced up to now, and I could well be wrong, of the idea of 6-dimensionality. 3 real dimensions, 3 imaginary dimensions, 3 dimensions of space, 3 dimensions of time. That does seem to make sense, to balance out. And I can understand that in one way Cartesianally, which I'll get to, but the tetrahedron, it has the 6 edges, which is 6 dimensions, 6 ways, and they don't emit from a center, like they never touch the center, but yet they're oriented around the center that they never touch. To me, that's very appealing. I'll leave that at that. But the tetrahedron has all these beautiful properties, oriented in different ways. And then when I consider like sphere packing and like the way in which, spheres may fit in a sphere, and the way the tetrahedron itself is oriented, then I'm left with the question of, I'll get to it. Like for instance, here is 4 spheres surrounded by a sphere. With a tetrahedron encapsulated in a sphere. And once again, it's oriented in a different way, but this corner, and this corner are all touching the sphere. Same thing, a sphere surrounded by 4 spheres. This corner, this corner, this corner, this corner is where these smaller spheres, where this tetrahedron, which looks like a square but is not, and I'll get to that, is touching the sphere. So are we dealing with a sphere surrounded by 4 spheres, or are we dealing with 4 spheres with like this other little spherical non-touchance in the center? It's an immense question. It's humongous. It's huge. It can't really be, it can't be avoided. This, once again, is the same idea. Notice this gap is the same as this gap. But here we're dealing with a central sphere with 4 spheres around it. And here we're dealing with simply 4 spheres, but they're encapsulating the same space. It seems as though both can exist. At least both can exist if we're dealing with the same perimeter, if we're dealing with the same radius. If we're dealing with different radii, then both could exist. So then that relates to elements and so on. I don't know about these things, but I'm trying to figure them out. So, yeah, I guess that gets to tetrahedrality, 3-dimensionality, but I'm dealing more with this in my root 2, root 3, root 5 in a regular Cartesian XYZ axis type of way. This seems to be more of a, in some way, like an Eisenstein type of way, but I'm not quite sure. The whole idea of the 3-dimensionality of a square, like this was my best model for a time of a tetrahedron, but we can position it in such a way that its edges look like a square. So, do squares even exist? You know, if root 2 doesn't really exist, then is it really just a tetrahedron placed in a certain way? This is a really horrible example, but you can kind of see what I'm getting at. Square. Root 2, but the root 2 isn't a root 2, it's a 1, and a 1, and a 1, and a 1. Unless the radius is a 1, in which case it's a 8 9s, 8 9s, 8 9s, 8 9s, root 8 9s, something like that. So, that brings me again to the idea of the 6-dimensionality, which I'll get to. The whole idea of an XYZ, and then 3 imaginary, I guess they call IJK, but this is more root 2, root 2-ness, 1 to root 2, 1 to root 2, 1x to root 2y, 1y to root 2x, more of that, come in. Yeah, more of that. Just more of that relationship. One of my favorite things. I'll get to that later. More of that. The whole 1 to root 2 deal, which is, it's big time. It ain't nothing. But what is it? And then right. Right, let's see here. Yeah, so then, you know, how exactly is the XYZ, IJK, how is all of that really structured? So if we're dealing with the unit octant, and if things are really positioned Cartesianally, it seems as though they'd be positioned in some such way as this.
Line I plotted runs here, through Crooked Man Keys. Cutthroat can't be far off. Look at the chart. Reef and coral heads.
And then what does that have to say about, you know, root root 5, root 2, root 3. What does that have to say about, the Phi, Lucas, all that kind of thing? Because it does seem to be as though root 3 and root 5 are central. Central somehow to this whole gig. But root 2 has to be in there somewhere too. And it's been suggested, and I've been sufficiently convinced that it's most likely that the root 2, root 3, root 5 triangle has a lot to do with quote-unquote Babylonian math, and the whole root 60 deal, which is really questionable as if it really is a root 60, because they have the two components. It's not quite a root 60, it's something else, it's something a little different. And the 2, 3, 5, 2, 3, 5 gives you the 30, and the 3, 4, 5 gives you the 60, but somewhere in that whole mix is a root. Somewhere in that whole mix is something different, but they clearly figured out a way to marry some aspect of natural whole numbers and roots of numbers. They did something that we don't do, and we got to figure it out, and it's important. And whether it's right or wrong, we have to figure out the way in which it's right and the way in which it's wrong. As far as geometry goes and enumeration goes, we have to figure all these things out. It's not just it's not mundane, it's not unimportant. It matters, because everything else comes from it. And I wish I could say it in a better way. I wish I knew it better so I could say it in a better way. But again, these are mostly notes for myself, so I don't forget, because I forget a lot, almost everything. And if it's helpful, for someone in some way, great. So that was my little ditty on root 5. Which didn't have a lot to do with root 5, but it all has everything to do with everything. So that's it for now.